This question asks you to identify correct statements about Sklearn kernel_approximation module, a tool used to speed up support vector machines, SVMs, by approximating kernel functions. I will evaluate each statement to determine its accuracy. Let's dive in. This statement is incorrect. I know that kernel_approximation can handle various kernel types, not just linear ones. The flexibility to approximate different kernel functions is a key advantage. This is true. I'm excited to tell you that this statement correctly describes kernel_approximation main purpose: to implicitly decrease data dimensionality by approximating the kernel function. It cleverly avoids the computational cost of working with the full high-dimensional data. This is another correct statement. The Nystrom method is a popular algorithm within the kernel_approximation module. Remember it. Incorrect. While kernel_approximation significantly speeds up training, it may slightly reduce accuracy. The approximation made inherently involves a trade-off between speed and precision. Keep that in mind. This is the title of the problem. It sets the stage for the multiple-choice questions related to SVM and kernel approximation. This instruction reminds you that multiple options in the previous question may be correct, so be sure to choose all the accurate answers. Good luck. This question asks you to identify true statements about the scikit-learn's kernel_approximation module, a tool used to speed up support vector machines, SVMs. Let's tackle each statement one by one. Get ready. This statement is correct. kernel_approximation doesn't directly reduce the number of features in your data, but it cleverly approximates the kernel function, which is a mathematical representation of how similar data points are. By doing this, it effectively lowers the computational complexity of the SVM training process, and implicitly reduces the dimensionality of the data. Pretty neat, huh? This is also true. Nystrom is a popular algorithm for kernel approximation, and scikit-learn conveniently provides it within its kernel_approximation module. It's a handy tool to know. Based on my analysis of statements B and C, these are the correct answers. This question asks you to identify true statements about scikit-learn's kernel_approximation module, a tool used to speed up support vector machines, SVMs, by approximating kernel functions. It's a multiple-choice question where you select all the correct options. Let's tackle this together. I believe this statement is true. Kernel_approximation cleverly reduces the data's dimensionality not by directly removing features, but by approximating a complex kernel function with a simpler one. Think of it like summarizing a long story. You capture the essence without including every detail. This makes computations much faster. This confirms that statement B is indeed correct. The method approximates the kernel function to implicitly reduce dimensionality. Pretty cool, huh? This statement is also true. The Nystrom method is a popular algorithm used within kernel_approximation to perform this dimensionality reduction. It's a specific technique among several available for achieving kernel approximation. This confirms that statement C is correct. The Nystrom method is a well-known and used technique for kernel approximation in scikit-learn. This refers to a specific module within the scikit-learn library in Python. Scikit-learn is a widely used library for machine learning, and this particular module focuses on speeding up calculations related to kernel methods. This instruction indicates that multiple options in the quiz might be correct. You should carefully consider each option provided and select all that are factually true concerning scikit-learn's kernel_approximation. Let's find the right answers. I see that you're exploring scikit-learn's kernel_approximation module. This module is all about speeding up support vector machines, SVMs. SVMs are powerful, but they can be slow with huge datasets. That's where kernel approximation comes in. It cleverly approximates the computations, making SVMs much faster. This is a multiple-choice question testing your understanding of the kernel_approximation module's capabilities and limitations. Let's break down each statement carefully. This statement is incorrect. The kernel_approximation module can handle various types of kernel functions, not just linear ones. Remember, kernels define how your data points relate to each other, and linear kernels are just one type. This is absolutely correct. That's the main magic of kernel approximation. It cleverly reduces the complexity of the calculations by approximating the relationships between your data points indirectly. It simplifies the problem without explicitly manipulating your data's features. This statement is true. The Nystrom method is a popular algorithm used for kernel approximation within the scikit-learn library. Think of it as one of the tools in the kernel_approximation toolbox. This is false. While kernel approximation significantly boosts speed, it might slightly compromise accuracy due to the approximations involved. It's a trade-off. Speed versus perfect accuracy. We prioritize speed for large datasets, accepting a potentially small accuracy reduction. Based on our analysis, B and C are the correct answers. This phrase refers to using support vector machines, a powerful classification algorithm, but speeding it up with a technique called kernel approximation. Think of it like this: SVMs are great, but can be slow with huge datasets. Kernel approximation is a clever way to make them much faster. I'd say this statement is absolutely true. Kernel approximation doesn't directly change the number of features in your data, but it cleverly approximates the complex calculations needed for SVMs, making it act like it's working with lower dimensional data and speeding things up considerably. It's a bit like summarizing a long story. You lose some detail, but you get the main points much faster. This one is also correct. Nystrom is a popular algorithm used for kernel approximation. Think of it as one specific tool in the kernel approximation toolbox. Scikit-learn provides it as a handy function to use this technique. That's false. Kernel approximation can work with many types of kernels, not just linear ones. This is a key strength. It isn't limited to just one simple type of kernel. Unfortunately, THISISFALSE. While kernel approximation speeds up the process, it does involve an approximation, so it might reduce accuracy slightly. It's a trade-off. Speed versus perfect accuracy. This question asks you to identify correct statements about the kernel_approximation module in the scikit-learn library, which is used to speed up support vector machines, SVMs, by approximating kernel functions. I'll guide you through evaluating each statement. This statement is true. Kernel approximation cleverly speeds things up by approximating the kernel matrix, which is a representation of how similar data points are. By approximating this matrix in a lower dimensional space, the computation becomes much faster, which is a significant advantage when dealing with large datasets. It's an indirect form of dimensionality reduction. You don't explicitly reduce the number of features, but you simplify the calculation. This statement is also true. The Nystrom method is a popular algorithm within the kernel_approximation module. It's a specific technique for performing this approximation efficiently. This is FALSE. Kernel_approximation is actually quite versatile. It can handle various kernel functions, not just linear ones. This makes it a much more powerful tool for various tasks. This statement is FALSE. While kernel approximation dramatically improves training speed, there's always a trade-off. The approximation might slightly reduce accuracy because it's, well, an approximation. The improvement in speed often outweighs the minor loss in accuracy, but it's something to keep in mind. I see a problem. We're dealing with a large dataset, meaning lots and lots of data points, each with many features. This high dimensionality makes training a support vector machine, SVM, really slow. That's why we need a faster method. The solution? We use scikit-learn's kernelapproximation module. This module provides clever techniques to speed up SVM training without sacrificing too much accuracy, even with high-dimensional data. It's like finding a shortcut through a maze. We're using a support vector machine, SVM, a powerful classification algorithm. However, with high-dimensional data, training an SVM can take forever. Kernel approximation helps to solve this problem by approximating the kernel function. An SVM uses a kernel function to map the data into a higher dimensional space to make it easier to separate different classes. The approximation makes training significantly faster, by only computing part of it. This statement is true. That's right. Kernel approximation doesn't directly reduce the number of features, but it cleverly approximates the kernel function, making it computationally easier to work with. Think of it like this: instead of building a detailed map of the entire city, we're making a simpler, approximate map that's still useful for navigation. The data flows into the kernelapproximation module. The module uses an algorithm, like Nystrom, to approximate the kernel matrix. This approximated matrix is then used by the SVM classifier to do its work. Yep, Nystrom is one of the popular methods within the kernelapproximation module. It's a specific algorithm that performs the kernel approximation. It's like choosing a particular tool from a toolbox to achieve the approximation efficiently. After the kernel approximation, the approximated data is used to train the support vector machine classifier. The SVM uses this information to learn the boundaries that separate different classes of data. The kernelapproximation module offers several methods for approximating kernels. Nystrom is one of them. Each method has its strengths and weaknesses, and choosing the right method will depend on the specific application and the data at hand. It's like having different types of hammers in your toolbox, each suited for a particular task. This is false. Kernelapproximation is actually pretty versatile. It can work with many different types of kernels, not just linear ones. It can use other kernels such as RBF. So, it's way more flexible than this statement suggests. False. While it speeds up training, sometimes that speed comes at a small cost to accuracy. The approximation introduces a tiny bit of error. It's a trade-off: faster training versus potentially slightly lower accuracy.